happy to introduce to you Francesco Degrassi, which is a quite experienced software developer. I think he has participated to our meeting, I don't know, 3 or 4 times. And every time his talks were one of the most interesting and fun. And his talk will be live, the one given by Vittorio before, and it will be in English. So, okay, please tell us something more about surviving microservices. Francesco, thank you.
Hello, everyone. Pleasure to be here today, this unconventional edition of Incontro DevOps Italia. I'm afraid today won't be as fun as the other years, but I'll do my best anyway. So my name is Francesco Degrassi. I come from 20 years of software development, but in the last few years, I've been more and more involved in consultancy activities, helping companies that deal with custom software built in-house to deal with the complexity of it, understand how to best evolve it, and so on. I'm a partner in Option Factory, which is a company that does this and more. We have a strong focus on lean software development. Let's say that we have expanded our offer by trying to help others build software with a strong offer in the consultancy area. And one of the services that we provide in the under this umbrella is very pertinent to what we are discussing today, which is the one regarding to technical due diligence. Basically, we work with companies trying to assess the quality of the software they have developed in-house, on which their business is based, to understand if it is fit for purpose, if it is maintainable enough, if it can meet the new requirements of the business. And in the course of this kind of activity, more and more in the last years, we have found that many companies have started actually adopting a microservices architecture for their platforms. Some of them have introduced a microservice architecture for new platforms and products. Others have decided to move towards a microservices architecture by refactoring their existing platform. In this scenario, all of the clients with which we work that have moved in this direction are paying the price in terms of training requirements, increased solution complexity, and increased operational costs and effort. But very few of the ones we get in touch, obviously our audience is skewed from this point of view, because if they need help, they usually are unlucky with their adoption, but few are reaping the promised benefits at all. And to understand why this is, it's better to start from what they report to us. So their complaints fall into 2 main areas. The first one is they're not seeing the benefits that they were expecting. So they report a lower velocity of the team in developing new features and integrating them, even though they were expecting the adoption of microservices to allow them to increase the throughput, to have to parallelize the development process. On the other side, another strong selling point for microservices is the ability to scale up, scale out services individually, and so better invest your resources, scaling up the components that requires that most. But that is not what they're seeing. In some cases, they're seeing that to achieve the same performance level as before, they need many more resources, much more hardware. In other cases, they see performance regressions altogether. And on the other side, they're affected by side effects that they were not expecting. So they often report a higher defects rate, which they were not prepared for. So they get a lot of customer complaints for lost documents, service unavailability, and so on. But the thing that is most present in the complaints of our customers is the lack of visibility. They feel like the new platform is not trustworthy because they're not sure what is going on. And when something breaks, they feel like that they cannot pinpoint where the issue is. So to understand why that is the case, what we are seeing as the causes of these issues with the companies that we work with, we really need to take a step back and outline what microservices are and what they offer and what they require. Citing Lewis and Fowler, the idea of a microservices architecture is to implement a single application as a suite of small services that can be deployed as independent processes, which communicate through lightweight mechanisms, usually REST APIs over HTTP. Microservices are more because the idea would be to build these services around business capabilities of the company, to make sure that they are independently deployable and automated in their deployment. And it also pushes for minimizing the amount of intelligence and logic that we have on the communication infrastructure. So moving away from enterprise service buses and having just a simpler network infrastructure that allows services to discover each other and collaborate, but the intelligence should reside, the smartness should reside inside the services themselves. This, moreover, opens a world of possibility in terms of implementation because having services independent in such a way allows us to choose the best technology stack for each and one service. And even from a data storage standpoint, they can be each service can choose the best strategy and technology that suits its needs. And it is a lot to process because here we are touching on several different areas. Some of these areas are around modeling. So it has to deal with how the components should be organized around business capabilities. Microservices architectural approach comes from the idea of evolutionary design, where we try and iteratively understand what part of the platform belong together by seeing their communication patterns, by understanding that things that change together should belong together. And these are all things that fall under the umbrella of a microservices architecture. But it also touches on organizational aspects, such that adopting a microservices architecture requires to move from an idea of project to an idea of product, where each service is developed by a cross-functional team that covers the software development, business, and operations aspect within the company. There is no handover once the development is complete, but the same team deals with a service, with a platform throughout its whole life cycle. There's an aspect around the infrastructure automation, which requires changes at the organizational level to be leveraged. And then there are obviously the technical aspects, such that deployment as individual processes, the idea of a smart services communicating over a simple networking infrastructure, and the aspect of decentralized governance, where each service can be managed, deployed, and its technology can be chosen independently, and the centralized data management, where the data of each service is of the service itself. Each service has its own model, and the storage of that data is the access to the data is only through the service API, and that data can be stored anywhere the service consider it most appropriate. There are other things important here, and there is the design for failure approach idea. When we are moving the complexity of our application in distinct services, what we need to cater for is that any call to a remote service can fail now. It is a situation that was not present before, and it is an essential part of developing a microservices microservices architecture, because any remote call can fail at any time, and it requires an awareness from the developers that is not usually required in other solutions. But there is a trade-off. As in any technology or architecture choice, there is always a trade-off. So we are deciding what is most important to us and what we believe will bring the most value, and the drawbacks that we are willing to confront, and the price they're willing to pay to get that benefits. In the case of microservices, there are four main points on the pro side. The first one is it's the ability to enable technology diversity, because any service can be implemented independently, and there are no limits to what we can do there. The second is the ability to independently scale each component. If I have a specific streaming service or a conversion service that requires many more resources than others, I can scale that up independently. That's the aspect of enforced module boundaries. It is hard to violate a module boundary in a microservices architecture, because we are dealing with an REST API that is exposed remotely, maybe by an application, by a service implemented with a completely different technology stack. So compromising on the boundaries that we have decided is actually difficult, and so enforced by the architecture itself. And finally, we have the idea that we can scale up development, we can increase throughput by decoupling each team to work on a different service. But this is not free. The price that we're willing to pay for this is that, first of all, we need to manage all the technology diversity that we introduce inside the platform. So maybe this has impacts on the fact that a developer cannot simply move from one team to the other, because maybe there is a mismatch in the skill set that is required to work on that service. And it might strain the HR department in finding the right mix of competence in applicants. On the other hand, we have the issue of distribution. A microservices architecture implies distribution of components and makes our application a distributed application. This introduces new failure modes that require handling, and it makes harder to reason about the behavior of the system as a whole. This is a compromise that we need to be aware of when we move in this direction. There is the fact that in a distributed application, we might need to deal with eventual consistency. And so we don't have any assurance anymore that the changes that we requested we apply on a service will be immediately visible by other services. And this might invalidate a lot of assumptions built into the software that was already there, or other platforms that were depending on the behavior of the previous system. And more easily, there are the increased operational complexity, because we have many more parts in movement, the higher trainer requirements, and the high impact of design mistakes. As much as we have strongly enforced module boundaries, on the other side of the coin, there is the fact that if we make a mistake in modeling a couple of services, if a concern should be moved from one service to the other, or should be merged from two different services when it is broken now, these kind of changes become architectural changes, and as such are much more costly to remedy. So we lose some agility to respond to unexpected events in this case. And this brings us to the first issue that we most often found as the cause for unsatisfaction with a movement to microservices architecture by our customers, which is lack of solution fit. Many times we find ourselves with customers that have already decided for adopting a microservices architecture before even discussing what the platform should do, who the team will be that will manage it, where it will be deployed, who will take care of the operation side of things, and so on. And this is a mistake because microservices architecture, I'd argue, is not for any platform, and it is not for every organization. When we look at a microservices architecture, we think about companies like Netflix, Twitter, Instagram, but the reality is that most organizations are not like that. Most of them don't have the simple business logic, huge scalability requirements, and risk appetite of something like Netflix. What I mean is that if you look at several different metrics or dimensions under which we can classify companies. If you look at, for example, at number of complexity of operation of a platform, such as that from Netflix, we see that there are few operations and they're pretty simple. I'm either subscribing, browsing a catalog of movies, or streaming a movie. There's more than that going on, but not much. In most of the situation we look instead, we find that we have many different types of operations, and those are much more complex. So, for example, we are modeling an insurance claim processing rather than procurement tender process, and the process is much more complex. It is much more difficult to model, and with microservices, any mistake in modeling becomes much more difficult to fix then. Emerging requirements are harder to accommodate. So in this kind of scenarios, it might not be the perfect fit. Looking at the coupling of components, we see the same behavior. So the coupling of components in Netflix is probably pretty low. It might be higher on average with the kind of companies that we work with. Then we have the issue of performance. If you look at concurrent users and the need to scale individual components, we see that Netflix operates with millions of concurrent users at the same time, while most of other realities operate on hundreds of thousands of concurrent users at the same time. And the need to scale up specific components is not always there, especially when the business operations are much more involved and complex. There might not be a clear cut where we see that some parts need to scale up more than others. In Netflix, this is obvious. Transcoding, streaming require many more resources than just browsing a catalog or subscribing new users. Microservices in this case don't help much and might just introduce a needed complexity. We have the issue of team and developers. Teams usually for Netflix can be tens of teams and hundreds of developers. Many other companies don't have the same kind of resources and are looking at few teams and maybe dozens of developers in total inside the company. And in this case, we cannot leverage much scale out of development on different services. Operational resources are abundant in Netflix, but are low on average on most of the companies that we work with, especially in Italy, where IT is seen as a cost center. And so the operational resources might be unable to cope with increased complexity that microservices architecture entails. We have team skill and training budget where Netflix can basically hire whoever they want. While on average, most companies have average developers. It's just a question of numbers. And in this case, we introduce the risk of implementation mistakes, which are much more costly in a microservices architecture, and maybe the inability to spot the potential issues in a timely fashion. Finally, there's the issue of risk appetite, where for a startup, for a company like Netflix, it's higher. Maybe they can afford to run two different to develop two different solutions at the same time and choose the one that works best. For most of us, that is not a given. The second issue that we see that is making such transitions fail is simply implementation mistakes. The first implementation mistake that we see oftentimes is the failure to address organizational change. Microservices architecture, as we were saying before, requires a different approach in how the organization works. Simply, if you think about cross-functional teams and the idea of project versus products, if we do not adopt these changes inside the organization, what happens is that operations and security requirements are not considered in development. It's basic DevOps here. And with the microservices architecture, it becomes much more difficult for an operations team to map the business processes over the entire platform, which might entail a fleet of 10, 20, 30 services. And in case of issues, this might make very hard for them to pinpoint the cause of problems, and then they would not have among them the competence to understand what is going on. Then there are mistakes in modularization. Oftentimes we see that services that should map to bounded context from domain-driven design are not as such, but are often too fine-grained. Sometimes there are just some REST APIs bolted on database tables. And as such, they do not expose transactional business operations, which they should. And in this kind of situations, what we see is that we see the not having transactionality across services is forgotten. And we find that we lose messages because of one service is failing and one other completing successfully in operation. And this has an impact on the quality of the service itself. We see mistakes in terms of API granularity. Network calls are expensive, and too fine-grained APIs are unsustainable. But oftentimes we see that maybe because the middleware that we were using for remote communication does not make that explicit, or because we make some mistake in the modularization and make two services too interdependent on each other, or because we are working from an existing code base and splitting out services, and we fail to adapt and don't understand that what was acceptable before, because we were talking about same process function calls, are now remote calls that entail network round trips and can take order of magnitude more time to be completed. We have mistakes in encapsulation, where data that should only be exposed to the service API is shared by different services. Shared databases in a microservices architecture are huge red flags. We have issue with excessive coupling, where different services maybe share code and models. But the idea of microservices architecture is that each service should be independent. It should be deployable on its own. A common mistake that we see is to build shared model libraries that are used throughout a fleet of services. This is indicative of an erroneous interpretation of what microservices are in the first place, because each service should have its own model and should map from other services model to its own when it communicates with them. And this is what happens if you violate this principle, is that basically you get a distributed monolith rather than a microservice architecture. And we see complexity moving into interaction. A common mistake that we see is that implicit state is moved into asynchronous messaging. So maybe now the only trace that document has been received and is being processed is a message in a queue. And this is a huge problem, because transient state in messaging infrastructure is the hardest thing to inspect and monitor. And so what happens is that messages get lost, and processes get interrupted and lost and not found anymore. And this yields problems with customers opening tickets and so on. The third issue that we face that impedes getting benefits from microservices is the failure to address the impact on non-functional requirements. A microservices architecture has a huge impact on NFRs because to satisfy the same requirements now requires much more. From an operability standpoint, we need a complete, extensive monitoring infrastructure that allows us to get a clear picture of the health state of each service. And it requires us to visualize how the services interact together and the health of the infrastructure itself. Then we have the need to deal with infrastructure and configuration management that might not be already catered for inside the company. And having many more things to deploy and configure requires much more investment in this area. We need, obviously, deployment automation. Deployment automation is a good thing per se, but in a microservices architecture, it becomes an absolute requirement, and it needs to be dealt with. We have the issue of service discovery, where services need to find each other and be made available based on their health status. We have the huge problems about tracing of business processes throughout multiple systems, where we must understand that an exception in a specific service might have caused issues on another service. And from a logging point of view, at the application level and globally, we need to provide enough context in logs to be actionable in a distributed scenario. And we need a centralized infrastructure that is easy to access for us to use in understanding the causes of issues that we see in production and so on. If we fail to address this impact on NFRs, what we see is, for example, a lack of visibility inside the status of the platform and in understanding what is going on. From a correctness, performance, and scalability point of view, we need to deal with the increased requirements in terms of skill set and training. We need developers and operational people that are familiar with concepts like DDD, who have experience on distributed system, which are well versed in continuous integration, continuous delivery tools, which are comfortable in infrastructure management. We need new tooling for tracing. And all of this need to be covered. We have the need to provide on-demand development environments for developers to be able to work in a situation that resembles as much as possible a production environment. And this becomes much more complex when I need to deploy 10 or 20 services for that. We need to look at availability, resilience, integrability, and compatibility. In this area, developers must think about compatibility, maintaining compatibility of the APIs, maybe introduce API versioning where necessary, and they need to cater for cascading failure scenarios, where now any of 10 different services can fail, many more pieces are at work, and the failure of each one of these might compromise the correct functioning of my platform end to end. From a data integrity, retention, durability, and disaster recovery point of view, we need to understand that it's implicit with a microservices architecture, but different services might be in a state that is misaligned to others. If I restore a backup for the accounting service, maybe the streaming service is streaming a movie to a customer that has never enrolled, because we needed to restore a previous backup and we lost a couple of transactions, and now the streaming service is streaming a movie to someone who is not a customer, and this is something that can happen and needs to be dealt with. From a security standpoint, we need to implement authentication, access control, and accounting throughout a fleet of services. And integrity and confidentiality of data in transit is now something that we need to deal with, while before it was just function calls within the same process. From a testability point of view, we need automation within the ability to easily provide infrastructure. Having come to this point, it might look like microservices are difficult, have a lot of issues, and if they are not appropriate for my case, then the only alternative that I have is the monolith. And this is not the case. I believe this is a false dichotomy. First of all, for your organization and you have the resources to implement them correctly and deal with the impact on non-functional requirements, then they are a good solution. But the alternative is not to necessarily have something like it's depicted here, where in a monolith on the left, we have a layered architecture where we have a UI layer, a business logic layer, and data access layer, and no separation of concerns within the different components inside. But this is a false dichotomy. It's not necessarily like this. The idea is that what we should try to look at as an alternative is something like this, where inside a single process, we are still applying all the good ideas that come with a microservices architecture. So we are enforcing strong module boundaries. We are decoupling components from one another in order to make them easier to understand, easier to manage, independently upgradable and evolvable. But the idea is that we just need to deploy that as a single artifact. We can even use different storage strategies inside the same application. We are not constrained in any way. On the other hand, by adopting an approach like that, we're not buying into the complexity of having to deal with network calls for inter-service communication. So the idea is that we were sold a false dichotomy from this point of view. It's not black or white. We have a whole lot of shades of gray from which to choose. A lot of the benefits that we expect from a microservices architecture can be had with a hybrid approach. So strong module boundaries in a microservices architecture are enforced by the architecture itself, which is hard to change by definition. But on the other side, we can and should make sure that strong module boundaries are enforced regardless of the architecture by the team itself, by empowering it to be responsible about keeping things organized and well decoupled. My thought is that if you need to enforce compliance on your developers, you might not be able to afford microservices because you don't have developers that would be able to model correctly the services themselves. From an independent deployment and scaling perspective, in microservices, it is possible. Even though it's not a guarantee that you will obtain the results that you want, because there are a lot of pitfalls and you might introduce other bottlenecks that invalidate the benefit that you get there. But it is possible, even when I have a single deployable, to reason about having independent deployment by opportunistically extracting a service. So I don't have a microservices architecture, I have a service architecture. And that makes a lot of sense because the microservices, I believe, has done more harm than good because it conveys the idea that the services should be as little as possible. Actually, they should be as little as it makes sense them to be. From a technology diversity point of view, in the case of microservices, it is totally unconstrained. I can basically mix and match whatever I feel like. Otherwise, I could be constrained with a single deployable, but again, I always have the possibility of opportunistically detaching a service, or I could use, I don't know, foreign function interface, JNI, and develop specific components with a different technology stack. It might not be as easy, but it is an alternative that should be considered. And finally, if you need to scale up the development by decoupling teams, you can do that by service in microservices, but you can also do that by component library or service itself, even if you have a single deployable. Maybe the deployment will need to be coordinated, but there are options there also, especially if the microservices architecture is not a perfect fit for you. So, well, now the point is, if you are in a situation where a microservices architecture was adopted and it is a mismatch for you, then you need to intervene. If you have implementation mistakes, you might need to do some changes. If you have to address non-functional requirements, you should do that. In any case, what we suggest is to seek external guidance. The idea is to assess the state of the project without preconceptions, to have someone who is not invested in the project to ask the hard questions that maybe weren't asked enough at the beginning of the process, and to create doubts about the choices that were made. A recommendation is to use our data in this process, such as mapping out how long it takes to bring a change in production, the number and kind of issues that are opened by the customers about the problems with the platform, and maybe measure the performance of the platform as it is, so to understand if it is meeting the requirements, and if not, you can use this data to understand if any change that you bring on the table is doing what you want it to do, if you're moving in the right direction. Planning for remediation, a recommendation that I feel comfortable with is that even if you have adopted a microservices architecture and it has issues, addressing the NFRs first can make the situation manageable short term. So basically what we have done in a couple of cases that we advise and help our customers, our clients, in creating dashboards for proactive resolution of issues due to mistakes in the implementation of the platform that create the breathing room that the team needs to fix the problems itself, instead of just being in a constant firefighting mode. In any case, avoid the sunken cost fallacy. If you have made a mistake at the architectural level, by definition, it will be costly and hard to fix. But there is no better time to change course than right now. Every new feature, every new development, any new change will bring you deeper into the hole if there are architectural issues. And so you should try to get out of there as soon as possible. Otherwise, you might find you behind where you are able to change course. About the changes that you want to bring, or if you're considering a microservices architecture for the next project, a couple of guidelines. Strive for simplicity, first of all. The question that you want to ask yourself is, what is the simplest thing that could possibly work? Many times when we confront with the clients, they ask ourselves, is it too complex to adopt this approach? And it is not a good question. I usually refuse to answer that question. I pivoted to, is there an actual need for any added complexity? Complexity grows exponentially, so you want to add to avoid adding any of it if at all possible. So you should try and find a justification for adding any amount of complexity, not trying to bargain with a complexity budget, if I'm being clear. In general, don't buy into the hype. Any technology choice is a trade-off, so make sure it is known and explicit what you're willing to pay to get the benefits. If this is not known or explicit, it's an issue, because you're taking up a huge amount of risk. Validate one choice at a time so that you can see what works and what not. If you adopt 3 or 4 different technology changes at the same time, you will not know what works and what doesn't. And finally for real now, make sure that the agency comes with the responsibility. We have seen too many times the phenomenon of seagull engineering, where a new engineer comes on board, a new CTO comes on board, introduces microservices, and then pads his CV, and after a year or two leaves before the fallout of any mistake is perceived by the ones that stay there. So make sure that whoever drives change is responsible for it and will be on board long enough to feel the pain of it, because at least it will become a learning opportunity for the organization and for the individuals involved. I'm done. I hope you found this useful. Don't hesitate to get in touch if you believe that, if you have any question, or if you believe that we might help in trying to work out where you are and where you would like to be. I hope you found all of this useful, and it has been a pleasure. Thank you very much.
Thank you very much, Francesco. I like your presentation a lot, full of interesting information. Since we have a couple of minutes before the next talker, I have a question for you. How do you handle this kind of issues in your company? For example, you wrote in one of the slides that there is this high impact of design mistakes. So you should strive not to do design mistakes, but nobody does design mistakes by choice. So it seems like you should try to be smart. But okay, let's say that I'm one of your customer and I ask you, okay, what should we do in order to minimize this design mistakes? What should we do in order to be smart? What would you suggest to that?
Okay, so I would take that from two different sides. From one side, the point is, if you are comfortable with the seniority of your team, with the experience that your team has had, everybody does mistakes. So basically, it comes down to a matter of experience and awareness. So if you are aware that you might be at risk of making design mistakes, I would recommend to try and avoid situations where those mistakes are too costly. So to try and keep the things as simple as possible in the first place. But there are projects where you need and are a good fit for microservices. And then in that case, you need to work on the other side. So you need people that have a lot of experience, that have made those mistakes before, and that have can match potential red flags to issues. There is no magic bullet, obviously. So the idea is either you have already done a lot of mistakes and you learn from that, and so you are comfortable that you can take more risk here because you are comfortable with maybe the problem domain is very well known and the technology is very well known and the team has been working together for a long time. And then you say, yeah, I know I might make some mistakes, but the probability is low. So even if the impact is high, that balances itself out. On the other side, if you have a team that has not worked for long or has not much experience or has not worked on distributed systems before, then you should avoid that, or maybe try that, but on a low-risk project, something where even if it fails, it won't bankrupt the company.
Yes, also you mentioned in another slide, and I'm going to steal that quote for my ever-growing fortune list, the one about how could the people who build the big ball of mud build a set of functioning microservices. Okay, I think we are perfectly on time. So again, this virtual clap is for you, and let's hope to see you in Bologna next year, getting normal. And thank you again for your participation to this meeting.